Let's take a look now at how to compute a sample size needed in correspondence with a confidence interval. You can think of this technique as complementary to the primary confidence interval technique, where with the primary technique, we're given a sample size and asked to find its corresponding margin of error, which then leads us to the interval values. What we're going to do here is turn that around, and we're going to be given a target margin of error and asked to compute the necessary sample size to come up with that. So determine the minimum sample size. Think of that as a key phrase that tells you that this will be that backwards technique needed to construct a 95% confidence interval for whale sightings on Alaskan tour boat trips. Okay, first part here, part A, we're told to assume a population standard deviation of 7 whale sightings. So in other words, for all Alaskan tour boat whale sighting trips, the standard deviation is 7 whale sightings. How many boat trips, in other words, what sample size, should be surveyed in order for the 95% interval's margin of error to not exceed 1 whale sighting? So therefore, E, or margin of error, of less than or equal to 1 whale sighting. And let's first of all come up with our z alpha half value. So in this case, we have an alpha of 5%. 1 minus the confidence interval leaves us with 5% outside of the interval. Half of that 5% represents the area in one tail, or 2.5%. And if we look at the z-chart, find the area 2.5% in the body of the chart, line that back here. That'll give us a z-score of negative 1.96, and we'll make that positive to come up with our z alpha half value to use for this part of the problem. Alright, having figured out the z alpha half value, let's jot down our formula to use to compute that sample size. And the operators on the outside of this formula, that's called a ceiling operator. That means if the result of the fraction comes out to be anything other than a whole number, always round up to the next whole number. So let's go ahead and populate this formula. Z is equal to 1.96, sigma is equal to 7, our target margin of error is equal to 1. We're going to square that result, then take the ceiling of it, and I'll go ahead and do that internal math, and that's going to give us a value of 188.24, which we still need to ceiling. And even though that would round down to 188, the ceiling operator says always round that up, and that gives us a final answer of 189 tour boat trips would be necessary to have a margin of error of a 95% confidence interval of no more than 1 whale sighting. Alright, good work. Let's look at part B here, and let's look at a proportion version of this problem. So confidence interval still going to be 95%, as we're told up top. And now we're told that 10% of all whale sighting trips result in not seeing any whales. So in this case, this is a proportion problem, and the success outcome is going to be a trip that doesn't see any whales. So for one trip to not see a whale, any whales, we're told that there's a 10% probability of that happening, or correspondingly that 10% of all whale sighting trips don't see any whales, and that gives us our population proportion that we're going to work with. How many boat trips would need to be sampled to construct that 95% interval of the likelihood of not seeing any whales to within plus or minus 2%? So keep in mind that we're now working a proportion problem, so therefore our margin of error is going to be a number of percentage points, and in this case that is 2 percentage points. So we'll go ahead and jot down our sample size for proportion formula over here, and let's go ahead and start populating that. So for the sample proportion here, we're going to use the population proportion that we're given. So 10% multiplied by 1 minus 10% multiplied by z alpha half. So still we have the 95% interval, so our z alpha half will remain 1.96. But you got to be careful here. The margin of error now is 2%, so we'll enter that as a percentage or a decimal value. Square that, and we'll wind up with the ceiling of that. So here we're looking at 0.09, the result of multiplying these two values, multiplied by 9,604, the result of this computation. And the ceiling of that, so that tells us that we want the ceiling of 864.36, or a sample size of no less than 865 will result in our margin of error for this 95% confidence interval being no more than 2%. Thanks for watching.